Hi everyone, I'm Cheryl. In this problem, we're going to be writing our quadratic function x squared minus 6x plus 2 in standard form. Then we're going to look at the graph of the function, and then we're going to look at some of the main features of the graph. So we'll begin by writing my quadratic function in standard form. To do that, we need to complete the square. So how do we complete the square? Well, the first thing we have to make sure of is that my leading coefficient is a 1. In this case, it is. So I'm ready to move on to the next step. The next thing to do is to take the b term, the term or the coefficient that is associated with the x value. We're going to take that value, -6, and we're going to divide by 2 and square it. So that's minus 3 squared, which is 9. Now, what are we going to do with that 9? Well, we're going to add 9 and subtract 9 to my function. So I haven't changed anything. So this will look like x squared minus 6x plus 9 minus 9 plus 2. Now, why would I want to do that? Well, if you look at these first 3 terms, when I group them together, I can factor them into a perfect square. So this will be the quantity x minus 3 squared. And then I'll group the minus 9 and the plus 2 together, and I have minus 7. F of x equals the quantity x minus 3 squared minus 7 is the standard form of my original quadratic. All right, let's go ahead and take a look at the graph of this quadratic. I know it's a parabola, right? And I know because the leading coefficient is a positive 1, it's a parabola that opens up. Well, the information that the standard form gives me that is really great is it tells me what the vertex is. The vertex in this case is going to happen at the point 3, -7. So I can go ahead and plot the point 3, -7 on my graph, which is going to be right about there. Again, I know this is a parabola. I know it opens up. Maybe a nice detail to get to figure out exactly how wide to make my parabola would be the y-intercept. That's easy enough to find because the y-intercept is located when x equals 0. So if x equals 0, y is going to equal 2. So it crosses right here. So now I can sketch in my parabola. So it looks something like that. Okay, the next thing I want to look at are some of the key features. One of them I've already talked about, and that's the vertex. So let me mark down the vertex again. The vertex for this particular problem is going to be the point 3, -7. Another thing that's interesting to get is something called the axis of symmetry. The axis of symmetry is a vertical line that passes through the vertex. So my vertical line that passes through my vertex is going to be right at 3. So my axis of symmetry is the line x equals 3. Now we've already talked about the y-intercept, but another nice feature would be to know where it crosses the x-axis or the x-intercepts. So let's go ahead and look at x-intercepts. To find x-intercepts, notice that what we want to do is find out where the y-coordinate is 0. So I'm going to go ahead and take my function and set it equal to 0. So 0 is going to equal x minus 3 quantity squared minus 7. It will be convenient to use the standard form because now when I want to solve this for x, I'll simply add 7 to both sides. Take the square root of both sides. Now be careful here. Remember, when you take the square root of 7, you're going to get plus or minus the square root of 7. And then you're going to add 3. So you'll have 3 plus or minus the square root of 7. Now if you want to get decimal approximations for this, we'll start out with x equals 3 plus the square root of 7. Now let me pull out my calculator. and 3 plus the square root of 7 is approximately 5.65. And for the x-intercept, x equals 3 minus the square root of 7. When I plug that in, 3 minus the square root of 7, I get approximately 0.35. And I notice that my original graph was pretty close. Here is the 0 that will be at 0.35, and here's the one that's located at 5.65. I hope that was helpful. Thanks.